So what we have here is we have an automobile coast through a 50-meter long snowdrift that has been blown onto the road. So if there's snow on the road, it's going to slow down your car, especially how, depending on how high the snow is. The automobile has a speed of 20 meters per second as it approaches the drift and emerges with a speed of 8. So obviously there was friction, there was work that reduced the speed. It says find the average net force acting on the car in the drift. Now, it says nothing about the road being a hill, so I can't assume that it went uphill or downhill. If it did, they would have to give me that information. So my starting point, like all the problems, is KO plus UO plus W equals KF plus UF. And like I said, we have to assume that it's a level road because they would have to give us some information about the hill if there was a hill in the problem. And we have both an original velocity and a final velocity, so we have an original kinetic energy and a final. The question is, find the average net force. So I am going to break this down into force times distance. If the question was, what's the work that's being done while the car is in the drift, I would leave it as W. So I'm going to write this as 1/2 mvo squared plus W equals 1/2 mvf squared. And that should automatically give me the correct sign of W. All right, it'll give me, if there's more energy here than there was there, then I'm going to get a positive work. If there's less energy here than there, I'm going to get a negative work. So, oops, I just told you what I wanted to do and I didn't do it. So let me erase this here because I said I'm not solving for work, I'm solving for force. So I'm going to write this as FD equals 1/2 mvf squared. Now in a problem like this, I have to know the mass because I can't cancel it out of all the terms. The rest of the problem is just a math problem. It's just an algebra problem. So we have fractions, so we're going to multiply by 2. We get mvo squared plus 2fd equals mvf squared. And so if we rearrange this equation to solve for f, I'm going to be moving this term to the other side, and then I'm going to be dividing by the 2 and the d. So that's going to be f is going to equal mvf squared minus mvo squared divided by 2d. So just plug in the numbers and you'll have the answer. mvf squared minus mvo squared divided by 2d. So for the mass, I'm going to put in 1.2 times 10 to the third kilograms there and there. I'm going to put in the final velocity as 8. And the original is 20, so I know that it slowed down. And it slowed down over a distance of 50 meters. So if you solve that, I know it's going to be a negative answer. What's the answer for that? Negative 4 point what? 4.03. Just that, or times 10 to the second. That doesn't sound right. Is that what I gave you? 10 to the third? All right, so. All right. So there's your answer. Any questions on that? So now all the questions are on you. Well, they will be on YouTube. So if there are any other ones that I didn't do, you can look at those. In the time that we have left, I actually finished early with you. So I'm gonna give you the time to work on the two problems I'm gonna check on Monday, which are 21 and 22. 21 is a very simple problem. It's probably less work than what you see on the board here. And